I want to relate. Came in yesterday, and he said, how are you teaching the kids to factor? Because this always seems to be of major concern. Jay, I need you to sit up, please. Okay? So he said, I said, I'm factoring by grouping. Normally I would teach the guess and check method, but I thought, factoring by grouping would be, give me some more success this year. And he said, I'm doing the same thing, but I looked online and I found this trick. And I'm not too big on tricks, but I was really intrigued by it because he said, I still have some math analysis kids that are still having trouble factoring. And so if they're never going to get it, the way we keep showing it over and over and over again, then maybe we need to come up with a new strategy. So we researched it. Another method that's very similar, but I think is more mathematically sound. Like I can kind of explain to you why it works. So here's the deal. So since I'm talking about 3x squared, right, that's like saying I've x squared and another x squared. I'm going to say take it away from the x squared and say it would be easier if I showed you algebra tiles. If I had -8, couldn't you say that if I were to take that 3 and multiply it by the -8, I'd have -24? Does that kind of make sense? So I'm going to kind of redistribute. I don't want to talk about 3x squared. I just want to talk about 1x squared. So I'm going to say I'm going to change this into x squared plus 10x's minus 24. Yes. I haven't had enough time to research it on why, but I have a really strong idea that it would be, if I looked at algebra tiles and was manipulating them, that I could figure it out. I just did this morning. So I'll get back to you on that, because that's a really important question. That's the only reason I was like, do I want to do this? Because of that question right there. Okay, so now this one's easier that we can do with that x, right? You guys can see it pretty easily. So I have -24. So two numbers I need to multiply to get to -24, and then I need two numbers that add to get to 10. 6 and 4? No, 6 and 4 is not going to work. Why is 6 and 4 not going to work? Because positive 6 and positive 4 is 10, but that's not going to get me a -24. 12 and 2? Does 12 and 2 work? 12 minus 2 is 10, and is 12 times -2 -24? Yes. Okay. So I'm going to take, this would have helped me out because I'm already forgetting. So I'm going to take my x and my x, split up my x squared, and then I'm going to take and -2, right? And then I'm going to, so originally what did I do to get the 24? Multiply by 3. So you can't just multiply something by 3, especially since I didn't multiply everything by 3. So to undo what I did to begin with, what do you think I'm going to do? I'm going to divide everything by 3. And I think I've just answered my own question right now. I'm not going to divide the x's by 3 because I never multiplied this by 3, right? So since I only multiplied the constant by 3, I'm going to divide the constant by 3. Okay? So now once I do that, I've got x plus 4. Now this is the only one that's going to kind of trip you guys up. Okay, I'm going to write a little side note over here. So if I had 3x minus 2 and I was trying to find the zeros, what did I tell you guys you could do? Divide by the 3, right? I want to know 3x's, I just want to know 1x. Isn't that what I have right here? X minus 2/3? See that? So instead of, I've got my own little problem in here. If I don't want a fraction there, I can just multiply both of them by 3. So when I multiply both of them by 3, 3x minus 2. Because when I multiply this by 3, and I multiply this by 3, the 3 goes away. What? Okay, but let me do it a little bit faster, and we'll see if you guys, because it's a lot faster than factoring by grouping. Okay? So I'm going to do it one more time really quickly, and then we're going to practice it. And you don't have to do this method. You can do factoring by grouping. You can do guess and check. You can do whatever works for you, but I'm trying to find something that sticks for everybody. J. Okay, so I'm going to do this one a little bit quicker. So I'm going to say, I'm going to redistribute that 2 to the negative 15. So I have x squared plus 7x minus 30, negative 30 and 7. Can you guys come up with two numbers for me? And negative 3, good. 10 and negative 3. 10 minus 3 is 7, but 10 times negative 3 is negative 30. Positive 10, negative 3. Use that 2 to make this bigger, so now I'm going to divide by 2. X plus 5, 2x minus 3. That seems like extra. You like it? Okay, so let's look at how we would do this by factoring by grouping. So right here, this is where we're at. So factoring by grouping, I would still use these two numbers, right? I'm going to do the factoring by grouping with blue. I would still use these two numbers. Grouping would be, so we're going to take this down here, by grouping. This is called the bottoms up method, by the way. Okay, so factoring by grouping would be 2x squared plus, now I'm, instead of using 7x, I'm going to use my 10x minus 3x minus 15. Then your next step was to group these two, and I get 2x 2x times x plus 5, and then I grouped the other one, negative 3 times x plus 5. You guys really think that this is faster? I mean, it's more mathematically sound. You can see the process, but I mean, you guys decide. I'm not understanding what you're saying.
I can show you what it is. It's basically the same thing, only I set it up differently.
Okay, I don't want to show yet another method to everybody, so why not you and I look at that, and then I can tell you if it's going to work every time. Sound good? All right, so should we start practicing? Yes? Oh my gosh, Kane, you're killing me. You have to show work. It's math. I would be doing you a disservice by letting you get through Algebra 2 without showing work, because I'm hoping you're going to math analysis, and then you're going to be screwed because you're going to get in this habit, which I can guess you're already in. So I'm going to pull you out of your habit. All right, guys, so whiteboards. Can you do number 10 for me, please? Sorry, Kaylee, I forgot to. Negative 3. 2 and negative 3. Let's check. 2 times negative 3 is negative 6. 2 minus 3 is negative 1. Good. So here are our factors. I've got A and 2, positive 2, and negative 3. I originally multiplied, so now I have to divide by 2. So I'm going to divide this by 2 and this by 2. I've got A plus 1, and since this does not simplify, I'm going to take the 2 and put it in front of the A. minus 3. I'm going to multiply both of these by 2. That's it. No. I can't hear the questions, guys. There's too much talking. It's very beginning. You now have to undo that. So you have to divide by 2. So if this was a 3, I would multiply by 3. And then at the end, I'd have to divide my constants by 3. Undo that. Okay, let's try another one. How do I know to put the 2 in front of the A? Because I multiplied. Guys, there's way too much talking. Okay? Way too much talking. Because I don't want a fraction here, right? Right? The benefit to having it in this form as well, right? That's your 0. But if you want it in traditional factored form, 2 and this by 2, it makes this 2 go away. So I get 2a minus. Be wrong. Yeah, Miss Liz, what would be the purpose for us to put it back into this? Right? I guess if I were to ask you to guess and to go back and multiply to check your answer, this is an easier problem to multiply. But this gets us what we want. That gives us our 0. So I kind of like it. You could leave it like that. I like it. Okay. 75% accuracy right now. So I'm going to erase this because I put it on a different screen anyways. I'm going to move, let's see, cover this up. Cover this up. Okay, Bryce, you and I are going to walk through this. Joey, I need him to look up here now, okay? Thank you for trying to help him out. Okay, so I don't want 2x squared. I only want 1x squared. So I'm going to redistribute this 2 right here. I'm going to redistribute the 2 over here to that. I'm going to multiply. So when I take this 2 and I multiply it over here, this turns into x squared minus 3x minus 10. You only do it to the 5, only to the constant. And at the end, we're going to divide, but we're only going to divide the constant. So now I say to myself, let's figure out our factors. So x squared times 10 is negative 10, and this is negative 3. Guys, negative 3. So what two numbers? When I multiply, I get negative 10, but when I add, I get negative 3. Sure. What two numbers when you multiply make negative 10? Negative 5 and 2. Let's see if this works. Negative 5 and 2 makes 10, negative 10. Negative 5 plus 2 is negative 3? Yes. So that's what we're trying to check. This is multiplication. This is addition. What two numbers can make negative 10 if I multiply? It looks like a plus sign. If I multiply. But what two numbers when I add make negative 3? So now that I have those two numbers, these are my those are my constants that go inside my factors. So here. So I have an x squared. I'm going to split that up into x and x. And instead of having this negative 10, I figured out exactly what two numbers I need. I need negative 5 and I need 2, positive 2. So here are my constants, right? So now in the very beginning I multiplied to get this bigger number. So now I got to divide. So I'm going to divide both of them by 2. I divide this by 2, it stays the same. So actually my 0 is 5 halves. And this one simplifies to 1. Some of you rather write it like this. The 2, if I don't want to have as a fraction, because we normally don't see that when we factor, I could just multiply both of them by 2, and it gets rid of the 2, and I end up with 2x minus 5. Right, does that help? Okay. 2x minus 5 times x plus 1, which is what most of you had. Yes, Chris. It doesn't matter which order it's in. What property tells me it doesn't matter which order it's in? Commutative, right? It could be either way. You guys want another one? Okay. So I think I'm going to go on to something a little harder. Okay. It's not really that hard. What do you guys notice about it? There's something else you should notice. They're all divisible by 2. They're all divisible by 2. So couldn't I take out a 2 from everybody? So I could take a 2 out of everybody, x squared, plus what is that, 18x, and 81? Do you even need the bottoms up method for this? It's just 9 and 9, right? Barry's got it. It's just 9 and 9 because I know 9 and 9 make 18. And this happens to be a perfect square trinomial. That's an easy one, right? You guys want to try one on your own now? I think we need to go back, just like Bryce said. He finally learned it, and then I want to go to a harder one. Let's go to this one. Let's erase this. What's the matter, Bryce? Let's do this one. Can you guys see this one? Better? Maybe. Let me pause it. 2, 1. Okay. So I'm going to. It sounds like we needed some steps. You guys want to put some steps in your. I don't want that. We could put some steps in your notes if you want. Let's write what our steps would be. So we want to, number 1, we want to multiply constant by coefficient of x squared. True? Multiply constant by coefficient of x squared. So I'm going to take that 5 and I'm going to multiply it by my constant. So I'm left with b squared plus 6b plus 5. These are our steps, so let's make them up together. I'm going to color code them. What's our next step? The x thing. So we're going to my next step is I'm going to do an x, where this is the a times c, that's the attic, and this is the b. And in the attic we're multiplying, just like we multiplied b 5 times, we're going to multiply 1 times 5, right? That's multiplying. And in the basement, we're just adding. So I'm going to do my little x over here. 1 times 5 is 5, and then I have a 6 in the basement. What two numbers? Erin, please. No, I want her up here. Please. We'll talk about it later. Okay, so I have a 6. What two numbers add up to 6 but multiply by 5? 1 and 5. So here's my two factors. I'm going to split up my, okay, now we need another step. Okay, what would be my next step? How do we put it in words? How do we put it in words that I'm going to do this? How do you want to write? Make two factors and distribute the constants? It's not distributing though. Just do this? Genius, Michelle. Love it. Okay, so we have this, and I know that I need my 1, and I need my 5, so plus 1 and plus 5. What's my last step? Divide by coefficient. Good word. Divide. We're going to divide by 5. So lastly, we're going to get, if I don't want it in fraction form, then I would move the 5 in front of the v. 5v plus 1 and v plus 1. How are we doing? Good? Lesson now? Barry? Yeah. Factoring by grouping, you would leave the 5. I need the talking to stop, please. I'm going to show you really quick, Barry, okay? Because I'm sure you're not the only one. It's kind of the same process. Guys. Attic that we're going to multiply. And up here we have the 6. That's our basement that we have adding. And we know it's 5 and 1. I think I started with this. 5b squared plus 5b, because that's my 5, plus 1b plus 1. And then I group. Sorry, what's bad? So when I factor out the 5b, actually I'm left with a v plus 1. And then when I don't have anything to factor out here, so I only have 1v plus 1. Does that make sense? There's nothing to factor out except for a 1. I can factor out a 1. So what I'm left with is I'm left with a v plus 1 and a 5v plus 1. So I think it's an easy way to do it. I think they're both good. Okay, let's make this method number 1, because that's the first one I showed you. And let's make this method number 2, the bottoms up method. Bottom up, let's make that number 2. Can you put fingers in the air? Which one do you like better, 1 or 2? Okay. All right, that's the one I'll go with. All right, let's get going. Like I said, there's not much new to this lesson today. It's more factoring and graphing. Okay, so there's only one new piece that I have to show you, and then I'm going to get you your homework, and we're going to start working on it, okay? All right, a tennis ball is tossed out a window that is 4 meters above the ground. The position of the tennis ball is given by this equation right here. It's a quadratic equation. So what does a quadratic equation shape look like? Looks like this, right? Obviously, since it's falling, it's going to be falling. This negative x squared, I could rewrite it as p of x equals negative x squared plus 4. Which is actually, if I factor out that negative, because I know it's going down, it would be x squared minus 4. What is x squared minus 4? It's the difference of two squares. Right? You guys recognize that? So this is a parabola that has the difference of two squares, and it's going down. It's going down because it's got a negative sign in front of it. Well, I know how to factor that really quickly. X plus 2, x minus 2. So I know that my zeros are at 2 and negative 2. Now, am I really going to talk about negative 2 in the negative 2 direction? Is something really going to fall off the ground at negative 2? No? No, right? So as I throw a ball out the window, it's going to take 2 seconds to hit the ground. That's what that does. That's a real-life application of quadratics. Okay? Which looks really complicated, right, until I turned it into this, and then it's not a complicated problem at all. So recognizing your difference of squares can just really make your life so much easier. Okay? I'm waiting, Matthew. No more talking. All right. So we're just going to do more of the same. Pencils down. So I ask myself these questions right here. Do we have a GCF? Do we have a difference of two squares? Do we have a perfect square trinomial? I see a GCF. Could I factor this? Yes. There's a way of factoring this. You could turn it into a trinomial by doing this. And then you could factor and go through all those steps. But why do that when I can already see it's got a GCF? So since it has a GCF, I'm going to pull out the GCF. That's 3. Actually, it's a 3x. And then I'm left with an x plus 3. That's in perfect factor form already. All right. This actually, we're trying to find zeros, right? So this would be 3x equals 0, or x plus 3, I shouldn't say or, equals 0. Well, 3 times what makes 0? 0. How do I solve for 0 here? What's x going to be? Negative 3. Now, do you have to do all that work? No. When you see this, a factor that doesn't have a plus or minus sign, you know that's automatically going to be a 0. That 0 is 0 on the x-axis. So I'm going to plot a 0. And I look at this, and I know that's negative 3. Negative 1, 2, 3. My intercepts, let's see. I kind of want to move this down just a little tiny bit, just for room. So my intercepts, I don't want to write x equals 0, x equals negative 3. I want to actually write them as pieces on a graph. So ordered pairs on a graph. So this is, I have a 0 at 0, 0, and I also have a 0 at negative 3, 0. Y-intercept. Do I have a y-intercept? Technically I do. There is a 0 there. So my y-intercept is also 0, 0. Do I know my axis of symmetry? It would be 1.5, right? Or negative 1.5. And of course, I don't like the way this one started. So yes, when we go in here, it'd be negative 1.5. negative 1.5. How do I find my vertex? Well, your vertex is an x comma y. And isn't your vertex also located somewhere on this axis of symmetry? So I technically already have half of my vertex done. I already know that my vertex, the x value, is going to be 1.5. So now I just have to find the y. So how would I find the y? You've got it right here, guys. Either here or here. Which one would you rather do? Because they're both equivalent. 3x without the square? Awesome. So I'm going to use this one right here to find my y-intercept. So 3x's, let's do it right here. So I have 3x's, which is 1.5. And I'm going to multiply that by 1.5 plus 3. 1.5 is how much? 3 halves is 1.5, 4.5. And what's 1.5 plus 3? 4.5. So what's 4.5 times 4.5? It's not 9. It's not 10. 18? Guess what I did wrong? This is negative 1.5. I should have had a negative sign here and a negative sign here. That's why this number is so big. Let's redo this. Do you guys see it? I should have had a negative in front of it. It's negative 1.5. I knew I was doing something wrong. So this is negative 4.5 times what's negative 1.5 plus 3. Now tell me what negative 4.5 times 1.5 is. What's negative 4.5 times 1.5? Who has a calculator? 6.75? It should be negative 6.75. How did I know I should have changed it to a negative 6.75? There's a reason why. Yeah, it's got to be going down because it's a positive graph. So it's negative 1.5, negative 6.75. So 1, 2, 3, 4, 5, 6, 7. So something like that.